All right, so let's talk about how we determine and rank the strengths of acids. And also we're gonna define something, define the difference between strong and weak acids. So essentially the strength of an acid depends on how easily the proton, the hydrogen ion, can be removed. So the easier it can be removed, the stronger the acid. So remember, the definition of an acid is something that donates hydrogens and increases the concentration of hydronium. So the easier that hydrogen is removed, the stronger the acid is. So remember, the more polar a bond, so there's a few different things that are going to determine how easily that hydrogen can be removed. One of them is polarity. Remember, polarity has to do with a separation of charge, a difference in electronegativity. So all of these bonds are covalent bonds, and polarity tells you how equally the electrons are shared between those elements. And the greater the polarity, the greater the separation of charge, the greater the difference in electronegativity, the easier that hydrogen is going to be donated. So a strong acid is an acid that will readily donate a hydrogen ion that will make the concentration of hydronium increase. So the more polarized the bond, the greater the separation in charge, the more easily the hydrogen is lost. So the more polarized the bond, the greater the separation of charge, the more easily the hydrogen ion is donated, the stronger the acid. So strong acids are molecules that will readily donate, easily donate a hydrogen ion. So let's just look at some trends that your book talks about that you will be responsible for. So the first one is binary acids. So a binary acid, bi means two, which means there's two elements in this acid. So usually they're represented as HX, where H is the acidic proton, and then X is whatever else. So as the atomic size of X increases going down a group, the acid strength increases. So the the bigger X is, the stronger that acid is, because there's a greater separation of charge. Another trend is with Oxo Acids. Oxo acids are acids that include oxygen. The more oxygens there are, the stronger the acid is. So for example, let's just look at an example here. So these are some examples. These are some chloric acids. So you see they all have an acidic proton that's going to be donated. But over here, this would be the weakest oxo acid, and this would be the strongest oxo acid in this example. So this weakest acid right here would be the least likely to lose a hydrogen. And this perchloric acid here would be the most likely to lose a hydrogen ion. So that's what makes it the strongest. So the more oxygens there are in that oxo acid, the less attraction there is between that hydrogen. The less attraction there is to the hydrogen, the more readily that hydrogen will be donated. When that hydrogen is donated, it's going to join a water molecule and form hydronium, and that's what makes it a stronger acid. So one thing that we need to talk about, we need to define the difference between weak acids and strong acids. I'm just going to put this over here. So a strong acid is an acid that ionizes completely. A weak acid is something that ionizes partially. So strong acids ionize completely. There are 6. There's 6 strong acids that you are going to be responsible for. These are the 6 strong acids. Everything that is not on this list is weak. So a strong acid is defined by that it ionizes completely. It doesn't have anything to do with the pH or how bad it would burn your skin or anything else. A strong acid is an acid that ionizes completely. So I'll show you what that means in a minute, but here are the 6 strong acids. Hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, perchloric acid, and sulfuric acid. You need to know these. You need to memorize these because everything that's not strong is weak. So the way that we solve and do all the calculations about acids, there's 2 totally different sets of calculations and rules for strong acids versus weak acids. So the first thing that you're going to be doing when we start to do calculations about acids is determine, is this a strong acid and use one set of rules, or is this a weak acid and use another set of rules? So these are the 6 strong acids: hydrochloric, hydrobromic, hydroiodic, nitric, perchloric, and sulfuric. Sometimes this one right here, which is chloric acid, HClO3, is included on the list of strong acids. These are the 6 that I will call strong acids and that you will be responsible for. Okay, So when I say it ionizes completely, what I mean is if you have HCl, it is going to break apart completely to H plus and Cl minus. This is a single-sided arrow. It is not in equilibrium. It ionizes completely. Ionizes just means breaks apart. Another word that you will hear kind of interchangeably with ionizes is dissociates. It just means breaks apart. So this ionizes completely. Everything that is not a strong acid ionizes partially. So what I mean by ionizes partially is that it exists in equilibrium, meaning it does not break apart all the way. Some of it breaks apart and some of it stays together. There are hundreds of weak acids. You are not responsible for memorizing the weak acids. You just need to know anything that is not one of these 6 strong acids is a weak acid. The generic formula for a weak acid that we use is HA. When we write the ionization of a weak acid HA, it's HA plus water, and then it exists in equilibrium, meaning that this weak acid partially ionizes. When this happens, it forms the conjugate acid of water, and it forms the conjugate base of whatever this weak acid is. We're going to see many, many, many examples. So the difference between a strong acid and a weak acid is that the strong acid ionizes completely. It ionizes completely. This is a single-sided arrow, meaning when this HCl gets put in water, it 100% ionizes. There is no HCl left. All of the HCl has broken apart to hydrogen ions and chloride ions. This hydrogen ion is then going to join a water molecule and increase the concentration of hydronium. All the other acids, weak acids, ionize partially, which means it exists in equilibrium. Which means when we put this weak acid in water, some of it breaks apart into hydronium and conjugate base, but some of it stays together. We are going to spend a lot of time on weak acid calculations and apply everything that we know about equilibrium from the last chapter to weak acids. We are going to do that later. We're going to spend some time talking about strong acid calculations first. So what you need to know about strengths of acids is that the strength of an acid depends on how easily or readily that hydrogen ion can be removed. Because when the hydrogen ion gets removed, it joins a water molecule and it increases the concentration of hydronium, and that's what measures how strong an acid is. The easier the hydrogen can be removed, the stronger the acid. This has to do with polarity. Polarity has to do with the difference in electronegativity. So the more polarized the bond, the stronger the acid. Trends that you should be aware of are that binary acids, if you're comparing two binary acids, as the size of the X, whatever the hydrogen isn't, whichever one is not the hydrogen, as that increases, the more polarized the bond will be, and the stronger the acid. Also, for oxo acids, as the number of oxygens increase, the more readily this hydrogen will be removed and the stronger the acid. You need to know these 6 strong acids. You need to know that everything else is a weak acid. Strong acids ionize completely, 100%. Weak acids ionize partially and exist in equilibrium.